Audio Jungle. Audio Jungle.
So, as you have seen from last 4 5 lectures, relay flow is what going on, right? Now you just see, based on this we had solved gate few questions also, normal question, but now we'll see the gate 2025 question was asked. And see the question paper, it is question number 50 and it was asked for 2 marks. Now the problem is, please write down. Now the problem is, see, a perfect gas, write it nicely. A perfect gas. Clearly they have mentioned ideal gas or perfect gas flows through a frictionless to a frictionless constant area duct. Constant area duct with heat addition the inlet conditions are as follows. Are as follows. They have given data pressure 100 kPa, the same problem, pressure 100 kPa, density 1 kg per meter cube, and velocity 100 meter per second. 100 meter per second at a particular downstream location or downstream location, the gas velocity is 200 meter per second. The static pressure, check, the static pressure at the downstream location is the fill in the blank. The in the blank kPa, right? This is the question. See, it was asked for 2 marks. So because relay flow is what going on, so without any doubt you may say this problem they have asked from the relay flow. But suppose a random question you have seen is in your exam, then first wording you will find that is the constant area duct, or second wording you need to find, is there any heat addition? Yes, see, is there any heat addition? So see, we have heat addition. Clearly, they have mentioned. It means it is surely a Rayleigh flow. Constant area duct or constant channel or sometimes combustion chamber also they can mention. But is there heat addition? Yeah, heat addition is there. It means it's a Rayleigh flow. Hope everybody understood, right? So here this is the constant area duct and we have heat addition. See, we have a heat addition Q. We can take as I had shown you. We can take because here the flow is what going on. Here the flow is what going on. This is nothing but Rayleigh flow. I have taken regimes here and I can identify any 2 points. Okay, here this is the point number one and this is the point. Check at point one that condition they have given area duct with the heat addition, the inlet condition. Clearly, it is clearly mentioned it is a inlet condition as follows: pressure 100 kPa, density 1 kg, velocity 100. So they have said pressure is nothing but at inlet 100 kPa. Density it is said rho 1 which is nothing but 1 kg per meter cube and it is 1D. So U1 is nothing but 100 meter per second. Correct? This is the inlet condition. Inlet condition. And they said at particular downstream location I have denoted by point number 2. The gas velocity is 200 meter per second. The static pressure they are asking at the downstream. So downstream location we have a 2. So they are asking basically velocity they have given at downstream. So it is downstream point is U2. So this U2 is nothing but clearly here it is mentioned it is 200 meter per second. And as you know, total pressure and static pressure, two different pressure we are having. So here they are clearly they are asking static pressure. You see this? They said clearly static pressure. Static pressure means P because it is downstream point is 2. So P2 they are asking. Right? This is the problem. Now think this is for 2 marks. We had solved problem also last class based on this very lengthy problem we had solved, very complicated problem also we had solved. Very it was very difficult problem last class we had solved Rayleigh flow. Generally such type of problem will be asked in your semester exam for 8 marks or 16 marks. Na? But we had solved. Why we had solved that lengthy problem? Because so many steps were there, and as I told you, in gate exam, very simple question will be asked, very direct formula based problem will be asked, and it is like two-liner, three-liner, four-liner question will. That is more than enough. I mean, 2 minutes hardly it will take 2-3 minutes, not more than that. That will be the gate problem. Okay, one pressure is given, density is given, velocity is given, and downstream location I have taken point number 2 that velocity u2 is given. That's all. So think, just apply your basic concept, uh, apply your basic equation, fundamental equation, uh, so many governing equation, fundamental equation, derived equation I have given to you, so many relation I have given for the Rayleigh flow. But if you go with very basic, what was the basic? Governing equation. Check. I have shown you for Rayleigh flow. What was the governing? How many governing equation I had given? Tell me, governing equation. How many governing equation I had given? Yes. Yeah. How many governing equation I had given? Anyone? First. Yeah. Continuity. Basically, mass conservation. What was the equation? Anyone?
Rho 1 U1 equal to rho 2 U2.
Good. It was rho 1 u1 is equal to rho 2 u. This is the equation number. Second, What is the another equation we have? I had given equation number 2.
Momentum equation.
Yes. Why I have, see, because in examination how you will think like this only. I mean, how you will approach any question, that is very important. So many question you have, so many things will come in your mind. But why you have gone through this governing equation? Because if you check in this, they have given velocity, density they have given, and velocity they have given. At second station they have only velocity. So first, if you see the data, so based on data immediately it comes in your mind why density at station 1 and why velocity they have given to you, and a second point only velocity they have given, so that easily you can calculate density. That value you can calculate. Once they ask the pressure, so immediately the formula will come to your mind. What formula? P2 by P1 is equal to 1 plus gamma m1 square divided by 1 plus that basic formula what I have derived. But we do not have m1 and m2, so it should be very clear. P2 by P1 formula you cannot use because they do not have given Mach number. Instead of this u2 or even u1, if Mach number somewhere it is given, so we'll try to approach in that way. But see, the Mach number inlet and outlet they have not given, velocity they have given. So immediately we have to think in examination what is the any relation basically related to the pressure and velocity. So immediately it will come to your mind, that is nothing but momentum equation. Tell me, Rahul, what is the momentum equation?
P1 plus
P1 plus,
rho 1 U1 square
okay,
is equal to P2 plus rho 2 U2 square.
this is the equation number 2. Simple. So you just find out from equation 1. Equation 1, just find out what is the rho 2. Because in second equation rho 2 is required. So what is the rho 2? Check rho 1 u1 divided by u2. All value you have, rho 1 it is given 1 kg per meter cube, and what is the velocity? U1 100. U1 is nothing but 100 and this one is nothing but 200. So what is the density? Tell me. It's a 0.5 kg per meter. Correct? Yes or no? Now go with the from equation number 2. You see the equation number 2. It's nothing but P1 plus rho 1 U1 square P2 plus rho 2. Here you have to calculate P2. What you will do? Take this data P1 plus rho 1 U1 square minus rho 2. All value you have now. All value you have. Check. P1 is nothing but 100 kPa, because I am writing each and every expression, all the equation I am writing. Otherwise, within 2 minutes you can finish this problem. 100 kPa. Okay, nothing but 100 kPa. And if you see the problem, they had asked value in kPa only. Check. They have asked the value in kPa only. It's your choice if you want. See, kPa only they had asked. So that time you need to remember the unit also. The dimension you should be very clear. Otherwise, again, you, as I have told you multiple time, I had told to students, if it is fill in the blanks, don't be in very hurry. Okay, don't be in very hurry. Slowly and slowly you have to see the all the, read the question properly, check the unit. Then while you are calculating, you go fast. But while it is fill in the blank, that time you should be very clear, because unit sometimes they are changing. They, instead of kPa they may ask Pascal, so you have to put value in Pascal. Megapascal also they can give, so that time you have to fill the value in terms of megapascal. So it is very important. Okay, fill in the blank. Now P1 is nothing but, as you have seen here, it is P1 is nothing but kPa. You can, it's your choice, you want to keep, you can keep in that way only. Ultimately P2 will be in kPa. Otherwise, if you want to write 100 into 10 to power 3 in Pascal, then that also you can do. It's your choice. I'm keeping here 100 kPa directly. Rho 1 is nothing but 1 kg. U1 is nothing but 100 square minus rho 2. Just now you have calculated 0.5 and U2 you have seen it. Calculate P2 value. Calculate this value quick.
So 90 kPa.
It's a 90. It's a 90 kPa. See, so because it's a fill in the blank, kPa is already given, so you have to fill 90. That's all. See, this was the gate problem, and it was recent one. You cannot say it. So maybe that pattern has been changed. No, it is not like that. See, it was 2025 last year question, and it was asked for 2 marks. And what we are doing here in our class, I mean, what level question we are solving you had seen, and what level practice you are having you had seen. It is very difficult, lengthy problem we are solving, because once we are solving very difficult, very lengthy problem, so steps we are learning, and in your gate exam that steps will work. Many places you had seen while deriving the equation, I had written governing equation. That's the reason I am deriving the equation expression also. So there nicely I had given the governing equation, and while seeing the data, immediately you can think, okay, with the help of only governing equation we can solve this problem. Because P2 by P1 problem you cannot apply here, because you need M1 and M2, and if you see data, they have not given Mach number and all. Even though at inlet temperature they have not given, you can calculate by using P1, P is equal to rho RT1 formula, that you can calculate. So even though you will get the Mach number, but again you have to find M2. How you can get that Mach number? Mach number you can calculate. There is no problem. U1 divided by root of gamma R T1. That you can do. But again, they have not given any information for the gamma R. It is air or gas. But don't worry. They in the problem itself they have mentioned it is perfect gas. If it is the perfect gas, so also, but see why you will go in this way, because again if you calculate M1 also, again there will be a problem for M2. So I would suggest, if such type of data they have given, so you have to think from very basic, very basic. Okay, like they had given density at they had given velocity at 2 station, at 1 station density they had given, so you calculate density as second, and because they are asking pressure, so use momentum equation. That's all. The problem is what's all there. I think it is that is clear to everybody.